In this video, we will learn to write different vectors in the 4-dimensional notation or 4-vector notation. This 4-vector notation is mainly used in special relativity, which is based on the Minkowski space. As Minkowski space is a 4-dimensional space, so we have to express each vector in the 4-dimensional notation instead of 3-dimensional notation. First, we will start with the position vector, which can be written in 4-dimensional form as x mu is. This can be further splitted into two main components. One is its zeroth component, which is x0, and the other as its ith component, xi. And they can be further written as x0 is the basically time component, which is time, and we will multiply it with c, speed of light, to balance its unit as the unit of distance or displacement. And this xi can be further written as x1, x2 and x3. Or if we use the Cartesian coordinate system, then this can be written as ct, x1 is x, x2 is simply y, and x3 is z. This is 4-dimensional vector in Minkowski space-time. Now we will take the example of 4 momentum, which is written as p mu, and similar to the above vector, we will express it in a zeroth component and an ith component. This zeroth component of 4 momentum is basically energy, which can be written as E over c. Again, here we are dividing energy by c to balance its unit. And this ith component can be simply written as p1, p2 and p3. Or if we use the Cartesian system, then this can be written as E over c, x component of momentum, y component of momentum and z component of momentum. So this is the 4 momentum vector in its component. Another example is the current density vector, which can be written as j mu, and again we can write it as a zeroth component and in its ith component. This zeroth component is simply the charge density, and this ith component is the 3-dimensional current density, which we often used in the electrodynamics. So these are some examples of 4-dimensional vector, and in all these we used an upper index notation. That is, in all these we have mu in the upper index notation. All these type of vectors which have an upper index notation are known as the contravariant vectors or the contravariant tensor. These are known as the contravariant tensors. We can write them in the lower index form. For example, we can write the position vector as x mu. Again, we will write it in the zeroth form and in ith form, which is again ct, and this is x1, x2 and x3. The vectors with lower index are known as the covariant vectors or the covariant tensors. So we will use here the general terminology that if we have an upper index, then our vector is the contravariant vector, and if we have a lower index, that is if we have an upper index, then it is contravariant vector, and if we have a lower index, that is a mu, then this is known as the covariant tensor or covariant vector. The last example which I am discussing here of 4D notation is our divergence operator in the 4-dimension form, which can be expressed as partial mu. And again we can write it in two components. One is its zeroth component and the other is its space component, partial I. This zeroth component can be simply written as the rate of change with respect to time, while this partial I is the simple divergence operator delta. So this is our example of 4-dimensional divergence operator. These are some common examples of writing our different vectors in 4-dimensional notations. Kindly subscribe this channel and share